Morning. Good morning. Uh, okay. In the last class, we are starting. I have started the 60 unit, that is introduction to programmable DSP. So already we have discussed about the architecture features of DSP processors. Okay, digital signal processing processors. Next, MAC, multiple and accumulator. So for fast operations, now we are using this MAC multiple and accumulators for doing the operations of convolution and correlation. Multiple and accumulator operation is required. Okay. Next, next one is MES, that is multiply and accumulator. Next one is MAM, multiple access memory. So here we have more number of memories. So two memory access, three memory, four memory access during the single clock cycle. Okay. Next, MPM, multiple ported memory, having the port. So it is multiple ported memories. Here address buses and data buses are separately interface here. Okay, this is the diagram. Here, this is the DL memory, DL ported memory, multiple ports, address bus 1 to address bus 2, address bus 3, address bus 4, like that. Address buses are there, and data bus 1, data bus 2, data bus 3, up to data bus N. So these two are separated, separately interfaced. Okay. Next, VLIW. This is very long instruction word. Okay. So this is here it consists of PCU, that is a program control unit, and FU, function unit, read write crossbar, multi-ported register file, and instruction cache. These are connected like this. Okay. Next is the without pipelining without pipelining, and with pipelining. So these are these structures are like this. Okay. So these are the pipelining. This is the pipelining concept, with the pipelining and without pipelining. Okay. So it consists of fetch, following instructions: fetch, decode, read, and execute. Okay. These are the instructions. And after that, we'll discuss about special addressing modes. So we have the addressing modes, immediate addressing modes, direct addressing modes, indirect addressing modes in microprocessors already we studied. So apart from this, we have the special addressing mode, that is a short immediate addressing mode, short direct addressing mode, okay, memory map addressing mode, indirect addressing mode, okay, bit reversal addressing mode, circular addressing mode, like this. So we have six special addressing modes are there, apart from the microprocessor addressing modes: direct, indirect, and immediate addressing modes. Okay, short immediate addressing mode, short direct addressing mode, memory map addressing mode, indirect addressing mode, bit reversal addressing mode, and last one is circular addressing mode, right? Circular addressing mode. Okay, right. Then coming to the architecture. So these are the up to here we discussed in the yesterday's class. So next, coming to the hardware architecture. Hardware architecture of the DSP processor is like this. So this is a DSP processor. So it is having a program memory and data memory. So program memory, storing the programs, it stores the programs, and data memory will use the results, starting the results. Okay, this will be modified. This hardware architecture will be modified as see here. This will be modified like this. This is the DSP processor. Okay, the same data memory and program memory is there. Okay, so this will be modified like this. Slight modification. Slight modification like this. Okay, data memory, data memory. Okay, here MACD instruction program multiply and accumulate in the memory access are required the following conditions: fetch MACD instruction from program memory, fetch one of the operands from program memory, fetch second operand from data memory, and fourth one is data memory write. So these are the MACD. What is MACD? Multiply and accumulator, multiplier and accumulator. Okay, instruction performs multiply and accumulate in the memory access. Okay, are required these the following conditions: fetch MACD instruction from program memory, it will fetch one of the operands from program memory, and it will fetch second operand from data memory, and data memory write. If this instruction is executed with uh, the MACD architecture, it requires 4 block cycles, but hard, hardware modified hardware requires less number of clock cycles. Okay, it requires 4 block cycles, uh, but the hardware requires less number of clock cycles. Okay, this is executed with one new man. See, one new one new man. One, this is abbreviated as VONNEUMON. One human architecture. Okay, it requires 4 block cycles, and but hardware in a modified hardware requires less number of block cycles. Okay, One human architecture. Okay, see, so what is one human architecture? So this is the general purpose processor. Normally, we have this type of architecture. The architecture shapes same memory for programming data. So shapes same memory for programming data. Right? The process performs instruction fetch, decode, read, and execute operations sequentially. So this process performs these instruction sets, instruction fetch, decode, read, and execute operations sequentially. After that, such architecture in the speed can be increased by pipelining. This type of architecture contains common address and data bus, that is ALU, MAC unit, and IO devices. Okay, architecture and the speed, it speeds. Here the speed can be increased by pipelining this type of architecture, which contains common address and common data bus, arithmetic logic unit, multiply and accumulator unit, and input output devices. This type of architecture is not suitable for DSP or DSP process. That's why we'll go for the hardware architecture. Okay, hardware architecture. So what is this? This consisting of this can be enhanced the speed by using by pipelining this type of architecture, which contains common address bus and common data bus, ALU, MAC unit, and IO devices. So this type of architecture is not suitable for DSP processors. That's why we'll go for the hardware architecture. The hardware architecture has a separate memory for program and data. There are also separate address and data buses for program and data. Because of these separate on-chip memory, the internal buses, the speed of execution architecture is high. So here these will be separated: address bus, data bus. Okay, address memory, data memory, these are separated. That's why the speed of the execution of architecture is high. Okay, from the figure we can observe that there is a PMA, program memory address, and PMD, program memory data bus. So this is the figure. PMA, program memory address, PMD, program memory data. Okay, program memory data bus separate from program Okay, these two are separated from the program. Similarly, there is separate data memory, DMB, data memory data, and DMD, data memory data bus, and data memory address bus. See here, DMD, DMD, DMA, DMD. Similarly, DMB, DMB, data memory data bus, data memory address bus. This is program memory address bus, program memory data bus. So these two are separated here. These two are separated. Okay. Okay, so the DSP includes various registers, addressing generators, and arithmetic logic units. The PMD, program memory data bus, is used to get instructions from the program memory, and DMD is used to exchange operands and results from data memory. The program memory data bus is used to get instructions. It will take or it will get instructions from the program memory, and the DMD is used to exchange operands and results from data memory. Data memory, program memory, data bus, and this is a DMD is a data memory data bus. Okay, the instruction code from program memory and operands from data memory can be set simultaneously is parallel operation which increases the speed. Okay, so the instruction code from program memory and operands from data memory can be set simultaneously. Simultaneously is the parallel operation which increases the speed. Next, modified hardware architecture. Modified one. So this is here we have two hardware architectures are there. So first one is a normal one. This one is a modified one. So here also program memory address bus, program memory data memory address bus, and data memory data bus. So here also we have the same buses. So it will explain like this. Modified hardware architecture. From this architecture, one set of bus to access program as well as data memory. The DMD, data memory data bus, can be used to transfer the data from program memory to data memory and vice versa. It is used to transfer the data from program memory to data memory. Okay, normally the program memory and data memory address are generated by the separated address generators. This modified hardware architecture is used in several programmable DSPs. So this modified hardware architecture is used in several DSP processors. Programmable DSP processors. Okay. Next, the sequence XFN. Next, we will do the small problem. So that is about the explanation of hardware architecture and modified hardware architecture. Okay. Next, we will go for this simple problem. The sequence x of n is equal to okay. Now we will do a small problem. A sequence x of n is given like this 0 to 468 is interpolated using interpolation sequence bk is equal to 1 by 2, 1, 1 by 2, and the interpolation factor is 2. 2. Find the interpolated sequence y of m. Okay, interpolated sequence y of m. So what is the given sequence? X of n is given as 0, 2, 4, 6, 8. Okay. So what is BK? Interpolation sequence BK is given as 1 by 2, 1, and 1 by 2. Okay. So what is the interpolated diagram? Interpolator diagram. So upsampler followed by low pass filter. X of n is the input signal. This is the upsampler, and low pass filter. Omega of m is nothing. W of m is nothing but output of this one. What is this? This is upsampler. Okay, right? So here interpolation factor is given as 2. So L value is 2. So we have omega of m, W of m is equal to x of n by 2. Okay, x of n by 2. So here we have L equal to 2. Okay, so this is the W of M is equal to M by W of M equal to actually it is W of M equal to X of N by 2 for 0 plus or minus 2 plus or minus 4 plus or minus 6 etc. Or otherwise it is 0 otherwise. Okay, so here we are taking the sequence of 1 2 3 4 5 6 7 8 9 9 number 0 to 8 numbers, that is 9 numbers. Okay, okay, so it will become 0 0 2 0 4 0 6 0 8. Why? Because this is 0 0, x of 0 is 0, x of 1 is also 0, x of 2 is 2, x of 3 is 0, x of 4 is 4, x of 5 is 0, x of 6 is 6, x of 7 is 0, and x of 7 is x of 8 is 8. Okay, y of m is having the formula sigma bk into w of m minus k. Okay, bk into w of m minus k. So it is equal to bk sigma n equal to 0 to 9, 0 to 8, 0 to 8. So if it is 0, b 0, y of 0, y of 0 equal to b 0, b 0, w of m minus 0. Okay, it can be expanded like this: bk into w of m plus 1 plus bk into w of m minus 0 plus bk into w of m minus 1 plus m minus 1 plus 1 0 minus 1. So here it is giving bk is given as a, here arrow mark indicates that bk of 0 is 1, bk of minus 1 is 1 by 2, bk of minus 2 is again 1 by 2. Okay, so bk has three values, right? So bk of minus 1 is 1 by 2, bk of 0 is 1, bk of 1 is 1 by 2. That's why here we are writing bk of minus 1, bk of 0, bk of 1, right? Okay, so this is bk of 0 into w of m plus 1, bk of 0, bk of minus 1, this is actually bk of minus 1 into w of m minus of minus 1, that is m plus 1 plus bk, middle one is 0, bk that is b of 0 into w of m minus 0 plus here it is 1, bk of 1 value, that is 1 by 2. So bk, that is b1 into w of m minus k, k value is 1 here. So that is m minus 1. Okay, now here values of b minus 1 value is 1 by 2, b of 0 is 1, and b of 1 is 1 by 2. So it is w of 1 value is what is w of 1 value? 0. W of 0 value is 0. W of minus 1 value is also 0. Minus 1, minus 1, 1, 2, 3, 4, 5, 6, 7, 8. Right? So it starts from minus 1. That's why we will take W of m values from minus 1 onwards. Okay, and here it is given as 8 means it is up to 8. We have to take in between these values are zeros. Okay, so right. So this is d of minus 1. D minus 1 is 1 by 2. 1 by 2 into 0 plus 1 into 0 plus 1 by 2 into 0. That is y of 0 value. Okay, now y of 1 value. If m is 1, then it is bk into yeah, omega 1 plus 1 plus bk into omega 1 minus 0 plus bk into omega 1 minus 1, right? So it will become b minus 1 into w of 2 plus b0 into w of 1 plus b1 into w of 0, like that, so that it will become 1 by 2 into 2 plus all zeros. This is 1. Similarly, y of, like this, we will calculate up to y of 8 values. Y of 8 values. Okay, 0 to y of 8. So that y of m will become 0, 1, 2, 3, 4, 5, 6, 7. It is clear? I will explain once again. So here the formula for finding the sequence y of m. So interpolated sequence y of m is sigma m equal to 0 to infinity bk into 0 to or b m equal to m equal to 0 to n minus 1, n equal to 0 to n minus 1 bk into w of m minus k. Okay, m is 0 to m minus 1. Okay, right? So this is the formula for finding the sequence y of m. Okay, this is the interpolator with the interpolation sequence y bk. Here the arrow is given at here, it means that bk of 0 is 1, bk of minus 1 is 1 by 2, bk of 1 is 1 by 2, right? Based on this, we will expand this one. So 2 means this is x of 2 value, 4 means x of 4 value, 6 means x of 6 value, and this 8 means x of 8 value, and this 0 means this may be x of 1 value. Okay, x of 1 value is 0. But here it is starting from minus 1, bk of minus 1. So x of 1 is 0, x of 2 is x of 0 is 0, and this is also 0. Minus 1 is also 0. Okay, minus 1. Otherwise, you can take like this, minus 1, 1, 2, 3, 4, 5, like that. So this is 1, 1 value is 0. Minus 1 is 1 value is also 0, right? Like that, first of all, we will write the sequence of w of m, that is 0, 0, 2, 0, 4, 0, 6, 0, 8. Similarly, and this bk is 1 by 2, 1, 1. Arrow mark is given at 1, so that bk of 0 is 1, bk of minus 1 is 1 by 2, bk of 1 is 1 by 2, right? Now we will multiply these two, so that by taking the values of m from 0 to 8, m from 0 to 8. So for every value, we'll calculate the y of 0 value, next y of 1 value, y of 2 value, y of 3 value, y of 4 value, y of 5 value, y of 6 value, y of 7 value, and y of 8 value. So that we will get the sequence of y of m, that is 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? This is the problem. And coming to the next one, next another problem is there. From here, okay. Next, coming to the next problem, that is the sequence x of n is given as 0, 3, 6, 9. Is interpolated using interpolation sequence bk equal to 1 by 3, 2 by 3, 1, 2 by 3, 1 by 3, and the interpolation factor is 3. Find the interpolated sequence y of m. Okay. So here L is given as 3. L is given as 3. Okay, x of n is 0, 3, 6, 9. Bk is 1 by 3, 2 by 3. Arrow is given at here, 2 by 2, 1 by 3. It means that bk of minus 2 is 1 by 3. Bk of minus 1 is 2 by 3. Bk of 0 is 1. Bk of 1 is 2 by 3. Bk of 2 is 1 by 3. So here L is given as 3. L minus 1 is 2. Okay, L minus 1 is 2. Okay, see, this starts from minus 2. Okay, so minus 2, minus 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is x of 3 is 3, x of 6 is 6, 4 5s are zeros, 7 8s are again zeros. Okay, 1 2s are zeros, and already minus it will start from minus 2. Okay, so 3 2 is 0, 2 is 0, minus 1 and 1 are also zeros. Okay, minus 1, 3, 1, minus 1, minus 1. Okay, so now is the right the formula y of n equal to sigma bk into w of m minus k. Okay, so bk starts from minus 2. Okay, b minus 2, b minus 2 into w of m minus of minus 2, that is m plus 2. b 2 into b minus 1 into w of m minus of minus 1 plus 1. Next, b1 b0 into w of m minus 0 plus b1 into, okay, w of m minus 1, v2 into w of m minus 2. Okay, right. Now we'll write this is m plus 2 here. First of all, y of 0, this is w of 2, m is 0, w of 1, w of 0, okay, w of minus 1, w of minus 2. Okay, so w of 2 value is, what is w of 2 value? 0. W of 1 value is 0. W of minus 1 value is 0. W of minus 2 value is also 0. Like that, we'll substitute these values. Okay, so then y of 0 will become 0. Next, replace m by 1. Okay, replace m by 1. Same values, replace m by 1. So it will become 3, w of 3, w of 2, w of 1, okay, w of 0, w of minus 1. Right? So substitute these values. Okay, so that we will get y1, y of 1 is 1. Next, replace m by 2, so that it will become w of 4, it will become w of 3, w of 2, w of 1, w of 0. So that we will get y of 3 is 2. Next, m become 5. So 5 plus w of 5, w of 4, w of 3, w of 2, w of 1. So y of 3 will become 3. Like this, up to 9. Then we'll calculate these values, so that y of m is 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? Clear? Clear? So first of all, based on the sequence, what is sequence? Interpolation sequence. Based on interpolation sequence, it will be calculated. Okay. So this is the interpolation sequence given. Okay. 3 minus 1, 2 means in between these two values are zeros. In the above problem also, here L minus 1 is given as 1. 1 means L minus 1 is 0 means 2 minus 1, that is 1. So we have 1 0. We have 1 0 in between this sequence. 0 to 2 1 0, 2 to 4 1 0, 4 to 6 1 0, 6 to 8 1 0. Like that we have taken. Okay. Here also, in this problem also, L minus 1 is 2. So we have two zeros. We have two zeros. So in between this sequence, 0 to 3, we will introduce two zeros. 3 to 6, we will introduce two zeros. Okay. And 6 to 9, we will introduce two zeros. Like that, we'll get the sequence W of M. Right? So like this, you can write the W of M sequence. After that, Y of M formula is there. M equal to 0 to 0 to 0 to M. Bk into W of M minus 3. Okay, but Bk values are already there. Okay, so we can calculate these values, so that finally we will get Y of M is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? These are very simple problems. Okay, with this I am concluding the today's class. Okay, already I have given some assignment questions to you. I have posted in your group, third year group. So you have to write those assignments in a separate 200-page notebook. Okay, and submit it on or before whenever the college reopens. Okay, whenever the college reopens, you have to submit the DSP assignment. Okay, so already simple questions there. Already I have given our whatever the questions we have explained in our classes. I have given those questions, and also they are very important. Okay, you have to write the assignment and submit it whenever the college reopens. Okay, thank you. With this, I am concluding the today's class. Thank you.